Hi everyone, a very good afternoon. This is Devanshi, your host for the session, and I welcome you all to the third chapter of Snowflake Educational Series powered by BluePi. In case you have missed out on our previous sessions, the YouTube channel link is provided in the chat box below, right there. Yeah. So now I would like to introduce our speaker, Mr. Rishabh Sengar. Rishabh has been working with BluePi for almost 3 years now, and he comes with an experience of working on ETL and data warehousing projects. Today, Rishabh will be giving us a short presentation on security and governance features of Snowflake. So over to you, Rishabh.
Hello everyone, and thanks for joining. Also, thanks Devanshi for an introduction. This is the third session of Snowflake Educational Series where we learn security in Snowflake. You should be able to see Q&A tab adjacent to a chat window. Feel free to post your questions there, and we will cover them in the Q&A session towards the end. So let's get started. In the last session, we talked about what Snowflake is, its history, underlying architecture, and other capabilities like how Snowflake is able to handle petabytes of data using massive parallel programming, how Snowflake leverages partitioning, clustering, and caching to provide us quick results, how we can undo a disaster by using time travel and failsafe, how does Snowflake achieve high availability. The agenda of this session is to provide you with all the fascinating features Snowflake provides us. Along with, we will be looking into all the security considerations while moving and maintaining our workload on cloud platform. Before diving into security considerations, we need to talk about the principle that form the cornerstone of any organization's security infrastructure. In fact, they should function as a goal and objective of every security program. When talking about security at organization level, CIA trade is one of the most important model which is designed to guide policies for data security. CIA stands for confidentiality, which means that only authorized individual systems can view our sensitive or classified information, whether it is in any form, in motion, or at rest. The next thing to talk about is integrity. Well, the idea here is to make sure that data is trustworthy and free from tampering at any stage of data lifecycle. Availability means that the network should be readily available to its user. This applies to both system and data. To ensure availability, the network administrator should maintain hardware, make regular upgrades, have a plan for failover, and prevent bottlenecks in the network. Keeping this gold standard in mind, we will now discuss security considerations at every level of data lifecycle. Let's go by an example. There is a company named Alpha. It produces large amount of data which is consumed on regular basis by its employee to generate report, do some reconciliation, to handle some analytic workload, and for some auditing purposes. Data creation is always the first step. Once the data has been generated, it immediately gets stored into storage system or network drive. On stored data or while storing data, there are generally two types of actions made by user or program. First, to do something like transformation, querying. Second, to load and unload some data. Since a company is producing very sensitive data, we need to make sure that our storage system is only accessible from few authentic IP addresses while querying, and loading and unloading of data is done via private channel only. Also, data should be encrypted at rest, also in motion. In this way, we can avoid phishing attacks, DOS attacks, man-in-middle attacks, which are major cyber threats to any organization. Since a company is big, we have different departments like HR, who are eligible to view employee sensitive information, finance, who are eligible to view balance sheet, but at the same time, an employee is not eligible to do so. Therefore, Now is the right time to set up access control frameworks which help us in defining data usage policies, and it can be achieved by different authorization techniques like role-based access control, rule-based access control, and risk-based access control. In this way, we can avoid data leakage and attack from malicious insiders. The data we have generated will be shared and consumed via different mediums like APIs, dashboards, drivers, or consumed by another group of users via client screens. Therefore, we need to have a secured way of gaining access to our systems, which can be achieved through authentication methods like MFA, OAuth, etc. In this way, we can avoid hijacking or misusing of our accounts. By looking into all the considerations, we have a well-designed security architecture which will cover all security features provided by Snowflake. Snowflake secures customer data using depth in defense with three security layers: network security, identity and access management, and data encryption. Network security provides the first line of defense against bad actors trying to access Snowflake customers' data. To safeguard against bad actors, Snowflake offers two types of controls for network security: private connectivity and using network policies. Snowflake's network policy feature only allow connection to known clients. We can declare a specific IP address range that can connect to Snowflake with other IP address ranges gets blocked. So now let's get into a demo where I will be demonstrating how network policies get into an action. This is a Snowflake screen, and in this, first we need to figure out what is our current IP address. So current IP address is this, and if I switch on my VPN, my IP address will change. So, so the first step is to create a network policy, and in network policy we have to define blocked IP address list, which will be, in our case, the IP addresses after keeping our VPN on, and allowed IP address list, which will be our current IP address. So this is a current IP address. So recheck it. We can pass a single IP address, or we can pass a list of IP address. Right now we are passing a list of IP address, and once we have started our VPN, on VPN, let's check what is the current IP address. As you can see, our IP address has been changed. So we need to block this IP address. So all the access from this IP address range will get blocked now. Let's go back to our current IP address, which is the allotted IP address, so that we can run this command. Policies, we can make policies using an account admin rule. As you can see, we successfully created account network policy. We can use account admin rule to describe a network policy. As you can see in the description, allotted IP list is this, blocked IP list is this. Again, using an account admin, we can set a network policy on our account itself. We have successfully implemented our network policy on our account. And let's see our parameters network policy. So our network policy is in action. So our current IP is allowed it, but what happens in case if I turn on my VPN? So I have turned on my VPN. As you can see, my IP address has been changed. Uh, I have to create again because my IP has been changed again. Just give me a minute. It will take few minutes to. So once I switch on this VPN again and refresh my window again, since my allotted IP address list, since VPN is on different IP address, as you can see, our connection has been denied because our IP address has been changed. In this way, we can Snowflake provides us capability to block any IP address range. So before moving, let's drop our network policy. Let's go back to a slide again. In the previous section, we were still using public internet to access a Snowflake instance, as you have seen. But what in case if we want our data to travel via a private network? This is where Snowflake Private Link Service comes in action. It enables direct and secure connectivity between VPCs while keeping network traffic and communication within the private network only. The two VPCs which we are talking about are Snowflake VPCs and the customer's VPC, which is hosted on AWS, Azure, or GCP. As you can see in the diagram, there are two ways in which we can access Snowflake via Snowflake Private Link Service, that is, from a virtual machine present in customer's VPC. Second, from on-prem via private peering or VPC tunneling. Also now, a SaaS application like Microsoft Power BI or Tableau that run outside of a customer's VPC can connect to Snowflake using a secured private link. Once a Snowflake account is accessible from a secured and isolated network, the next step in gaining access to Snowflake instance is to set up IAM, Identity and Access Management, which can be defined as a discipline that enables right individual to access right resource at a right time for the right reasons. To achieve this, we need to understand what authentication and authorization is. Talking about authorization, authorization is the process of giving someone the ability to access the resource. This can be achieved via access control frameworks. Snowflake Access Control Framework contains few key concepts which we need to understand before moving forward. Secure objects, which include databases, tables, stages, warehouses, which needs to be secured by gaining access. Privileges, privileges define the level of ability to perform the SQL action on an object. Example, ability to update and insert data into a table, ability to create a new database and warehouse in an account. A role is an entity to which privileges on an object can be granted and revoked. There are two types of roles, system defined roles and custom roles. In the upcoming slide, we will be talking about system defined roles. Users Users are those who need access on secure objects and via which we gain access to Snowflake instance. There are five types of system defined roles which Snowflake provides us. Account administrator role, which manages all the aspect of an account. It inherits the privileges of a system admin and security admin, and it sits on top of a role hierarchy. Security admin role can monitor and manage users and role as well as any grant globally. User admin role can create role and users. System admin role has privileges to create and manage warehouses and databases in an account. All custom roles are recommended to roll up to system admin role. Public role is automatically granted to all users in the account. The object owned by the role are available to every other user and the role in your account. Now let's talk about access control models on which a Snowflake's access control model is based. In discretionary access control model, each object has an owner. Access of an object can be granted to other users by its owner only. Next model is role-based access control model. In role-based access control model, we always follow an order. First, privileges are granted to roles by object owners. Second, roles are then associated with different users to restrict or allow actions to be performed on that object. Now, the central idea of Snowflake access control framework is that the role with which object is created will be the owner and has discretionary access control on it. Once the object is created, RBAC comes into the picture where access privileges on object are assigned to roles which in turn can be assigned to different users. Each user can have multiple roles and vice versa, but can assume only one role at a time. Also, role can be assigned to other roles, which means role hierarchies are allowed in Snowflake. As you can see in this example, role 3 has a select privilege, role 2 inherits privileges select, role 1 inherits privileges select and create. User 1 has assigned role 1, which means all three privileges. User 2 has been assigned role 2, which means select and create privileges. So in this way, we can achieve role hierarchy. So let's go to a demo of Snowflake Access Control Framework. So in this demo, we will be creating two separate environments, one for production and another for UAT. So the idea here is that production user can only view his objects and UAT user can only view his own objects. In this way, we can see how that works. Post that, we will see how role-based access control work. So let's drop. So first step is to drop if there are any existing role of previous session, and drop all the users if there are any. And the first step begins from here. We will be using a role system admin to drop a schema if there are any. And next step is creating a production user using a role user admin. Next, we will be creating a UAT user using a role user admin. Using a security admin, we will see our users now, whether we have successfully created or not. As you can see, we have created a UAT user and a production user successfully. Next step is in this is creating a database, a schema, and table using a system admin role. So in our case, system admin role is an owner of database, schema, and tables of production. And in case of UAT database, UAT schema, system admin is the owner. So let's see if we are having. So as you can see, we are having only system defined roles right now. Now let's create a role for a production user and for a UAT user to do their operations successfully. Once we have created a role, let's check whether the roles has been created successfully or not. As you can see, there are now production support role and user UX support role. Once we have created role, next step is to grant privileges to the roles. So we are granting database usage, schema usage, warehouse usage, and select on tables of production database to prod support role. And we will do the same in case of UAT. Now we will be granting roles. Production user will be granted role prod support. UAT user will be granted support. Will be granted role UAT support. So let's run this and try to log in into prod user and check whether you successfully granted roles on that object or not. As you can see, we are now using prod user. Let's create a worksheet, and the roles which we have assigned are production support only. We have given him the access to use grant to use a warehouse. So as you can see, we are having a warehouse also. On the left side, you can see there is a database prod db, and in prod db, as you can see, the owner is system admin, and via a role we have granted access to production db to prod user. In this way we can do the same for UAT user also. So right now we have demonstrated how uh, DAC works and few things related to role-based access control. Next, we will be seeing how next we will be seeing how we can leverage role-based hierarchy. Since we have granted UAT support to UAT user, so only UAT user will be able to view UAT support UAT support roles grants provided to UAT support role. So now let's grant all the privileges provided to production support role to UAT user also, and see whether we are able to leverage role hierarchy or not, or either we are able to provide multiple roles or not to a user. Uh, let's log out. Let's log in into as a UAT user. As you can see, now two roles are assigned to UAT user. One is production support, and to production support we are having two databases. We are having production databases and production tables. Along with that, we are having UAT support, which was originally assigned to it. So in this way, we can see how Snowflake achieves access control framework. Let's move on to slide once again. Since we have checked how access control frameworks are being achieved in Snowflake, let's talk about authentication. Authentication is a process of recognizing a user's identity. It is a mechanism of associating an incoming request with a set of identifying credentials. There are many ways in which we can achieve authentication in Snowflake. As you can see in this diagram, Snowflake supports two types of authentication, two types of OAuth basically. Snowflake OAuth, where it accepts token from built-in OAuth server. External OAuth, where it accepts token from third-party OAuth server. External browser authentication only works for client application running on user's machine. It must have a browser access as a driver opens up the system browser, redirecting the user to Snowflake login page for authentication. Otka native authentication, as the name suggests, only works with Otka and has limitations such as MFA, which must be turned off for the user in Otka. This is a legacy method and is recommended to use only when client application supports this method and hasn't added support for OAuth yet. Snowflake UI supports password and federated authentication using SAML, and we can authenticate Snowpipe using a key pair. Next, Snowflake recommends creating a spreadsheet listing of all the client applications connecting to Snowflake and their authentication capabilities. If applications support multiple authentication methods, then we must use a method in a below priority order. The first preference is always given to OAuth, whether it is Snowflake OAuth or external OAuth. Second preference is given to external browser if it's a desktop application that doesn't support OAuth. Third preference is given to Otka native authentication if you are using Otka and the app support this method while not supporting OAuth or external browser authentication yet. Key pair authentication mostly used for service account users since this requires the client application to manage private keys. Password should be the last option for application that doesn't support any of the above option. This option is commonly used for service account users connecting for third-party ETL applications. Once the user is authenticated, Snowflake creates a database session for a user. The client application can then use the session to submit queries into Snowflake. Each session has a 4 hour of idle inactivity timeout. Using a session, yeah. So using a session, new child session can be created. For example, Snowflake Classic UI creates child session 1 per sheet. As for best practices, reusing existing session from your client application to receive the best performance and avoid delays due to new session creation. Close your client application's connection when no longer required. Example, calling connection.close method from a Python driver. Avoid using session parameter client session keep alive to true unless necessary to unless necessary for the use case. Too many session creations with this parameter set to true put stress on resources and can lead to poor performance. If next we will be talking about few data governance practices. So if we want to restrict the access to sensitive information present in certain columns such as personally identified information or financial data, then Snowflake recommends using the following data governance features that allow you to restrict column access for unauthorized users. First is dynamic data masking. This is a built-in feature that can dynamically mask column data based on who is querying it. Second method is external tokenization, which integrates partner solutions to de-tokenize data at query time for authorized users. And the basic difference between these two methods are at rest, data is not being masked in case of dynamic data masking, but in case of external tokenization, data is masked at rest. Talking about third capability, secured views. So first we need to talk about what is the difference between a secured view and a normal view. In case of normal view, which is built on top of a table, creating a subset of columns and creating from a subset of column and subset of rows, we can view its DDL and we can view all the defined functions for a view. But in case of secured view, we cannot view these informations. But along with that, secure view comes with a problem of non-optimization. They must be avoided as secured views can execute more slow than non-secured views. When deciding whether to use secured views, you should consider the purpose of view and weight the trade-off between the data privacy, security, and query performance. So the next capability which Snowflake provides as a row level access control. As you can see in this diagram illustrated, the primary challenge here is that to ensure data is only visible to specific individual which have a need to know. If the user is not allowed to view the data, it is simply is not visible. Even the DBAs and account admin and table owners have no access to data unless authorized. So let's get into a demo of dynamic data masking and uh, other key concepts. So let's first clean our screen first. Okay. I think I need to create a new session again. So let me log in into this once again. And so we have selected a system admin role with and a warehouse attached to it. Let's clean our screen first. Once we have cleaned our screen, let's create a database. Along with that, we will creating a schema. So database already been in place. Let's create a schema. So in this schema, we will be creating a table name customer, which is having a customer ID, customer name, email and age. Since email is a sensitive information, so we will try to mask this email for one role and will be unmasked for the owner itself. Since system admin is an owner, he will be able to view the roles itself as it is, but another role won't be able to do so. Next step is in this is creating an masking policy email mask where where if the role is role analyst, then he won't be able to see the data. But if he's in system admin, he will be able to see the data. Now apply this masking policy on our table customer. As you can see, we have successfully implemented masking policy on the table. Let's view the data, email data using an owner system admin role. As you can see, we are able to view the data. Now let's create a role who won't be able to see the data. So while creating a role, we are using account admin. We are creating a role analyst, providing him all the privileges on demo database, granting him to access compute WH default warehouse. Along with that, we are granting this role to user Azure. In this way, we have successfully granted all the privileges to role analyst. And using this role analyst, let's see whether we are able to see the mask data or not. Let me run this query again. As you can see, we get an email column with masked data. In this way, we can achieve dynamic data masking for any role. And another feature of masking is that once it can be defined only once, but it can be used n number of users. So, so let's get into another demo of secured views. In secured view, we talked about that uh, for a secured view, the definition we won't be able to see the secured views definition, but in case of normal view, we can make sure that we are able to view the definition itself. So using a role analyst, we are creating a view and we will try to view the definition of this secured view. So as you can see, role analyst is the owner of secured view, and using a system admin role, let's try to view all the views. As you can see, secured view definition was not present in this by using system admin role, but if we use role analyst, we will be able to view the view name itself and all the information related to it, like who is the owner, what is its DDL, and everything. Is it secured or not? Is it materialized or not? Since it is not materialized, it is showing us false. Next, let's get into a demo of row access policy. So in this demo, we will be looking into two users, East and West. So East user should be able to view records of East related records only, whereas West user should be able to view the West related records only. So the first step of creating a user itself has been completed. Now let's create a schema named RAC rack. We have successfully created a schema in demo, and let's create a table itself and insert few values. So as you can see, we are creating a sales summary table where we are having sales ID, we are having this the amount which we have sold, we are having the amount which was targeted, the product name, and in which region we have sold our items. So this is the table which we have created, and now let's view this table whether we are able to create it or not. As you can see, we are able to create it, and owner of this table is system admin. Now, now we will be creating another table. This is called a mapping table, and in this mapping table, we will be having a region name and a region group. Region name defines what is the region, whether it is east or west, and region group will be defining the role name, whether which role will be able to view which region's data. So we have created a table. Now let's insert some data into this table. So we are inserting two values, region name as east, and the role which can view the east data is role region east. In the same way, we have created west with, and the role which can view its data is role region west. Now let's view this table's data. As you can see, we have successfully created. Now we have created a user. We have created all the tables and all the schemas related to it. Now let's create a role. The role has been created. Now let's Once the role has been created, let's grant him privileges on the database, schema and warehouse, and all the select operation which we want to do on this schema rack. We are granting the same permission to both the roles, as you can see. Next, we will be creating a row access policy using by running this command, and we will be applying this row access policy to our table sales summary. Once we have applied this row row access policy to our sales summary, now let's grant this role to our users respective respectfully. So now we have granted role east to east user and role west to west user. Now let's log in into another Snowflake instance and try to access. Give me a minute. Yeah. So now what we will do is that we will be using east user and check what are the permissions which we have given to this user. So let's go to a worksheet, and as you can see, the role region east has been assigned to it along with the data warehouse, and we have attached a demo database with the rack schema. Now let's run. So we will be using role east, and since we have attached row access policy to sales summary, we will be able to view only the data of east user. So let's run all these commands. As you can see in the result, only the region which is east is being shown here, and in the same way we can showcase for the region west to the user west, only the west records will be seen. He will be able to see. So in this way, we can achieve a row access policy, and we can also apply dynamic data masking and see how different secured views work. Let's get back to the presentation. In the previous in the previous section of security layers, we have talked about how Snowflake manages network security in IAM. Now we will talk about innermost layer of security, that is data encryption. As we all know that Snowflake provides us end-to-end encryption, which is a method that prevents third parties from reading data while at rest or in transit to and from Snowflake. Apart from end-to-end encryption, Snowflake provides us two features which are the best features. The first feature is Try-Secret Secure. Before talking about Try-Secret Secure feature, Snowflake has Snowflake encrypts thing in a hierarchical key model, and using this hierarchical key model, as you can see in this diagram, files are encrypted using file keys, table master keys are different, account master keys are different, and root keys are different. So Try-Secret Secure features uses both customer managed keys along with the Snowflake managed keys, create a new uh, composite key to encrypt the account itself. And the leverage of this feature is that without the permission of customer, Snowflake cannot decrypt the data. This security method also means that in the event of data breach, we can prevent Snowflake from decrypting anything. Therefore, shutting down all data processing in our Snowflake account. Next feature is periodic rekeying. In Snowflake, all the Snowflake managed keys are automatically rotated by Snowflake when they are more than 30 days or old. As you can see in this diagram, data files are being encrypted using table master keys in month of April, and in month of May they are encrypted using another version of table master key. In month of May, the data of month of April will be decrypted using table master key version v1, but it will get encrypted using version v2. In the same way, in month of July, the data will get encrypted using table master version v3, but the data of May and April will get decrypted using table master v1 and table master v2. In this way, Snowflake rotates the keys, but our cycle of rekeying doesn't end here. Snowflake automatically destroys the key once it is older than an year. So as you can see in 2018, we have some data which was encrypted using table master version v1 in month of April. In month in next year 2019, the same data will get decrypted using table master v1, encrypted will get encrypted using another version of table master key version v1 generation 2, and now there will be a new key with which the data has been encrypted, and in the same way it will get processed in month of May and month of July. So in this way, Snowflake achieves encryption, and so thank you. That's all. Yeah. So let's go to Q&A session and pick a few questions we have. So what is the impact of rekeying on failsafe? So in case of rekeying, just yeah. In case of rekeying, rekeying is a transparent feature. However, it takes some additional storage in case of failsafe. So it's just a transparent feature. Is security admin allowed it to create a network policy as well? Uh, I think yes, he is able to do so. And can multiple masking policies be attached to a same table? So we cannot attach multiple masking policy to the same table, and it goes with row access control, and it goes with dynamic data masking both. So at a time, only one table can be masked, and yeah, in case of grant of masking policy, what happens when future new data is added to the table? So, masking policies in case of future grants, these are not supported yet. So, in case of both dynamic data masking and row access based policies, both doesn't support future grants. Only workaround is to assign a role to that user and so on. So, I think these were the questions. Thank you, everyone.
Thank you, Rishabh, for such an insightful session, and thank you for all the attendees. I hope this session will be really helpful for you in your real life. Please don't forget to provide us your valuable feedback on the email provided below. And also do follow our social media handles for the further updates on upcoming sessions. Thank you, everyone. Thanks for joining in.